Now it's your turn to solve an equation that contains multiple radical expressions, each with variable expressions inside them. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. The equation that we're given here has the square root of the expression y plus 4 on the left, and then on the right side of that equation we have 1 minus the square root of y. Our general approach is that we will isolate the most complicated radical expression, square each side of the equation, and then again isolate the radical expression and square again. So let's get started. Taking the square root of y plus 4, we're going to square each side. So we'll square the left side, and then taking the right side with 1 minus the square root of y, we'll square that expression. Looking at the left, the square root of y plus 4, quantity squared, will give us y plus 4. And on the right, we have this binomial 1 minus the square root of y, and that's squared. We could use a shorter method for multiplying that out, or we can write it out as a product of 1 minus the square root of y times 1 minus the square root of y, and then expand it. So I've written it out in that expanded form, and then I'll multiply it out using FOIL. So the left side is going to stay as y plus 4, and on the right side I'll multiply that through. So those first terms, I'll get 1 times 1, which is simply 1. For my outside terms, I'll have 1 times the negative square root of y, so I'll have minus the square root of y. Inside terms, I have the negative square root of y times 1, so I'll have minus the square root of y again. For the last terms, I have the negative square root of y times the negative square root of y, so I will have plus that quantity square root of y squared. Again, keeping the left-hand side as y plus 4, we'll write then that that's equal to the right-hand side, and this will simplify. 1 is going to stay as it is. That negative square root of y minus another square root of y, I will have minus 2 times the square root of y. And then the square root of y quantity squared simply becomes y. So at that last term I have plus y. At this point, I have simplified that original equation, but I still have a radical. So I need to isolate the radical term that remains. So that negative 2 times the square root of y, I'm going to isolate. In order to do so, I want to get that all on its own. So the first thing I'll do is to subtract y from each side. And when we do that, we'll get 4 on the left side, and then we'll simply have 1 minus 2 times the square root of y on the right. Continuing on, we still want that negative 2 times the square root of y on its own, so we'll subtract 1 from each side. When we subtract 1 from the left side, we'll simply have 3. And when we subtract 1 from the right side, we'll just be left with negative 2 times the square root of y. To get that square root of y on its own, we'll divide each side by negative 2. So we'll have 3 over negative 2 equal to the square root of y. At this point, I need to square each side to get y on its own. So I'll do that in my next step. And that 3 over negative 2 I'll write as negative 3 halves. And that square root of y, I will square that. On the left-hand side, when that negative 3 halves is squared, I'll get positive 9/4. And when I take that square root of y and I square it, I'll simply get y. Now, we need to make sure that we formally check our solution. Again, we're checking both for errors and for extraneous or false solutions. So when I go through my check, I will replace each instance of y with 9/4. So I'll get the square root of 9/4 plus 4, and that's on the left side, and I'm checking if that is equal to 1 minus the square root of 9/4. To simplify that left side, I want to combine 9/4 and 4. I'll give 4 the same denominator by building it up to be 16/4. So I'll have the square root of 9/4 plus 16/4. And on the right side, I want to simplify this. That square root of 9/4 I can write as the square root of 9 over the square root of 4. Continuing to simplify that left side, 9/4 plus 16/4 will give me 25/4, and that's still inside the square root. On the right side, I have 1 minus that square root of 9 over the square root of 4, and that simplifies to 1 minus 3 halves. The square root of 25/4 is what I have on the left. I'll make that into the square root of 25 over the square root of 4. Checking, does that equal 1 minus 3/2? I'll rewrite this one as 2/2 minus 3/2. And as our last step, this left side is going to simplify to 5/2, and that right side is going to simplify to -1/2. So we can see that these did not check. So this was in fact a false or an extraneous solution. So 9/4 did not check. It was the only proposed solution. So we know that no solution exists. And we could write that solution set as the empty set. If we go back to this line that was third from the bottom there, we had 3 divided by -2 equal to the square root of y. And that was the point at which we could have conceptually identified that there would not be a solution. We had a negative on the left side, and that square root of y was the positive root. So that was the point at which we had a little bit of a hint that there would not be a solution.